Okay, my friends, it just never ends. I'm trying to get to the Geek Fest, where we're literally going to go over all of physics, from light particles to subatomic particles, all the way up to things that are in outer space. And what happened was I was getting a bunch of little pictures about light particles and so forth. And I ran into the Einstein ring, which I had forgotten all about years ago. I was looking into them because, they claim it's a galaxy on top of a galaxy. It's not. It's absolutely not. And I thought maybe it could be something to do with actually particles in space. Now, what I have found in the other things that are in space are just phenomenally, unbelievably large and totally unexpected, as is Bennu, which they just came back with a sample from. I'm going on in a minute. But this is the key right here. So, boom, Geek Fest stops, and I focus in on this, which to me has exactly the properties of dipole electron molecules and atoms. Exactly identical to the properties I would expect of an atom, not of something out in space. And here's where it came from. This is, it was a shot of some galaxies and so forth. These are the Webb telescope. When they went out there and started taking all kind of pictures. And the pictures are nice. I like the pictures. But the pictures do not represent distance. They think there's no particles in space, there's no fields. All that's nonsense. The total saturation of particles and fields in space, which slow down light, so they're not being pulled away because expanding. It's being slowed down because it's slowing down. It's very simple. And I can show light has different speeds. All of this stuff I was going to throw in at the Geek Fest. And then, boom, I hit this and I said, whoa. Interruption of Geek Fest. Well, I got to, this is my problem. I am too fragmented. I have too many things on the plate at one time, and I can't go from the potatoes to the meat to the salad to the this to the that to the boop to the boop. And I all of a sudden stop and start eating one thing at a time. But what are you going to do? It's too complex. I need a way of formulating this to where it's edible, so to speak. Right now, it causes a little indigestion for most people. Okay, my friends, it just never ends. I was getting ready to do the Geek Fest with electricity and magnetism and motors and generators and inertia and energy and all that stuff. And I was also going to do about Pistis Sophia and about the light, and everything was about the light. Everything is about light. So I decided I'm going to grab some pictures of light and so forth, and boom, the Einstein ring pops up. And I forgot all about that. Where is, here it is right here, look at this. Now, Pistis Sophia talks about going into the light of lights and doing the treasury of the lights and so forth. That is not just they say this is the shadow of a galaxy on top of a galaxy, making it look like something special. No, that is something special. Now, I'm going to get into this, and I'm preceding it because I got into it and I showed all about the structure and how the different colors and the intensities of light and so forth. And that, to me, is a molecule or an atom. That's what I'm seeing. Now, again, I was going to get into the Geek Fest, but it sort of, then there was the Gnostics, and then it ended up being a ramble. Because the things in space, they can't pay attention to what they find. They brought back this stuff. This is biology they brought back. It's here on Earth. They know it's biology, and they just can't accept it. They just cannot accept it. And I will show you this in so much detail. And here it is right here, Boulders and Beyond from Bennu. Billions of dollars, over well over $1 billion spent. And they came back with this heart muscle right here. And that's what it is heart muscle. And the same stuff is up on Mars. You see this here? This is heart muscle. And there's a heart muscle victim here on Earth. Now, I show all this stuff, and again, it got into a rant and a ramble and so forth, but I find that that's the way I learn the most, because I did discover a couple of things just even today that I hadn't considered. As you start rolling down a road, after you do the same road enough times, you realize, wow, I missed that, I missed this, I missed that. And then all of a sudden, a lot of the stuff starts to fall into place. These are the membrane layers. These are the sarcomeres. They are the exact same thing they came back with from Bennu. These are the membrane layers. These are the sarcomeres. Not hard to understand. These are the muscle fibers. Now, I'm going to show all this in great detail, and my brother's coming over, so I got to get out of this. Okay, I'll talk to you later. But it's gonna run for quite some time, about a little bit of a ramble. But it's all right. Let me just start this off by saying I was going to do the Geek Fest about electricity and magnetism and light and heat and energy and all that stuff, and so I went to get some pictures of light, and I saw the Einstein ring, which is this right here, which I had forgotten about. And this is way out in space. Now, at the same time, you guys know I'm doing a Gnostic text about, you know, the universe. What's the universe made of? Who's Pistis Sophia? Who's the invisibles? All of that stuff. It's just stunningly complex. But when you see things like this, and you see the explanation they give for this, they say, oh, that's a galaxy behind another galaxy, making one galaxy look like it's something it's not. No, it's not. It is something it is, because it is what it is. And now I'm going to go deep into all of this, but you can see all of the energy fields. The intense is in the center, less and less and less and less and less. That is exactly what dipole electron flood theory predicts, which is the new model of the atomic model. And I have shown, well, I'm going to show it again, I'm sure, today, all of the different aspects of light, how light forms a wave, but it's a particle, and how it can accelerate, and how it manifests itself, and how it is a particle, and how it's made of black and white particles, and how it flows through the air unseen. And then all of this stuff in space that we don't understand. We don't understand literally anything at this moment. And when they came back from Bennu, they came back from Bennu right here, which is a heart. That's a heart valve right there. That's a heart valve right there. And that is another one right there. That's the aorta. They went down there, grabbed a chunk of that. They came back with it. I knew it was going to be a heart. I knew it was blood, but I couldn't believe it when they came back. They actually had muscle. They went deep inside and grabbed it. And that's muscle with layers of sarcomeres. Sarcomeres, this is a membrane, phospholipid membrane, phosphate. Phosphates, sarcomeres, phosphates, sarcomeres, again and again and again and again and again. And here's what the sarcomeres are right there. And they are the exact same phosphate layers and sarcomeres as is on heart attack victims here on Earth. Right there, phosphate layers, sarcomeres. Now, again, I've gone over these things many, 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 many times. People say, oh, you keep going over the same thing. Well, as soon as people start to talk about it, well, we're off the case, and then I can sit back and watch. But until then, you're going to have to keep hearing it. And I go through about Mars and all that, and don't give me them nonsense about there's no Mars. We're going to get into all this stuff. And then we're going to go back to pistis and all the other things that are just not understood. There's nothing understood anymore. It's just absolutely incredible. And there is no appetite to understand anything from either side. You can show all the evidence you want to show. If a person's got an attitude, that's it, it's done. And they will attack you with arrogance. No, you're an idiot. You got to read page 27. And it goes from both sides. Page 27 in a religious text, and page 27 in a scientific manual, the same thing. You read it and you repeat it, or you're just an idiot. No, I look, I think, and this is what you're going to see. If you want to think, you think with me. Okay, my outstanding friends. Okay, my outstanding friends. I am getting closer and closer on Pistis Sophia to try to understand this. And something that was very interesting, I just thought about moments ago, was that in the Gospel of Thomas, one of the statements is, search And don't stop searching. Basically, don't give up until you find. If you're going to search, you better really search. You can't just search and say, oh, I figured it out in 10 minutes. No, it doesn't work that way. And it says, search until you find. When you find, you will be disturbed. I mean, literally disturbed. And then you will marvel. And that, so far, all of that stuff, literally everything I'm seeing, is coming true. And it's not just the Gnostic texts, it's all the ancient mythologies. They wrote truth, they wrote history, mixed in with all this mystical stuff that to us just doesn't seem possible. It's impossible. But when you start to see the giant creatures and the body parts that are in space, and I mean, it sounds insane, but it is a fact. If you can't deal with that, you can't search, you can't deal with reality, you're going to have a problem. Your whole existence and my whole existence, as far as I'm concerned, is here to learn about reality, however crazy it may seem. Dragons, giants, gods, battles in the heavens, eternity, planets that are living entities, that are creatures that have emotions. I'm getting deep into this, and I'm going to recap as I go along because it's so complex that you can't just pick up in the middle of it and say, okay, here we are and everything's fine. No. And you can't just do this quickly. This is a very, very deep, long understanding of what our reality is. If we could, how close can you get to understanding it? As I see right now, I have found nobody that's even anywhere close, and as I am not close either. I'm not saying I'm ahead of anybody. Trust me, I am in the mud with everybody else, trying to figure out, and there is a point you're not going to ever figure out anymore. Nobody ever knows where God came from. I can't even imagine how God would know where he came from. He's just there one day and starts making things. How would God say, where did I come from? Well, we say I came from my mother's womb. Well, where did she come from? Well, she came from her mother's womb. And when you get back to the beginning, where did that all start? Nobody knows. Nobody knows. And so don't go down that pathway because it just leads to madness, literal madness. You cannot figure that out. Let's just take, something is running this entire operation, the universe. As far as I'm concerned, something has to be running it. As far as I found, 100% of everything is biology. And I'm going to just make a couple of statements today that I've been mulling over about us being bacteria and viruses. Because we can control the things that are around us. That's what bacteria and viruses do. Bacteria create programs, literal programs, and they ball them up in a little ball called a ribosome. They send them out through the body, and that is the chemistry that does chemistry so fast it would take millions of years to do the same amount of chemistry as happens in 1 second because of a bacteria. It's an enzyme. So what is that bacteria doing? It's controlling its environment. It's control. It says, there's somebody trying to attack this guy. Let's go out there and kill him. Or there's some food coming in here. Let's go down and break it up. Or there's some trash collecting over here in the arteries, over in the wherever. Let's go clean that up. That's what bacteria do. They're living little creatures that are intelligent. As far as I'm concerned, extremely intelligent. And the programs that they write are an enzyme that can do more chemistry, like a chemist, in 1 second than would happen in 1,000,000 years without that little piece of chemistry that came from the bacteria. Bacteria says, squirts it out, and there it goes. And they're tiny little things, and when it gets called on, there's a little trigger. It gets methylated. It says, okay, turn on. It pops out like that, and it's so elegant that it causes half-life. within fractions of seconds that would take up to millions of years, even billions now they found. It's just staggering, the ability of matter configured into viruses and bacteria. They are literally, they do everything that's done on this planet right now. They do everything that's in you. If they weren't in you right now, you'd fall over dead. Right now, you're dead. No enzymes, you're dead. That to me is a pretty important component of life, is the enzymes. And they are from bacteria. We have thousands and thousands. We have about 75,000 bacterias, apparently at least, because there's 75,000 apparently known enzymes. And the bacteria are the only thing that creates the enzymes. Enzymes are so elegant, they just don't pop out of nowhere. And they found all of these things in the sample they came back with from Bennu, which is an asteroid in space, and it is a giant heart. All right, you have just seen or will see the Einstein rings, and here's what they're saying. The bullseye pattern are so-called Einstein rings, which are the most elegant manifestation of the lensing phenomena. This is not lensing. Einstein rings are produced when two galaxies are almost perfectly aligned, one behind the other. So they're saying there's one here, and then there's one behind it that's sticking out certain little bits and pieces that make it look like it's like a ring. I totally disagree. All right, this is the most elegant Einstein ring I have seen, and I'm not sure where it is, but it's an Einstein ring. And they're claiming that there's a galaxy behind this galaxy, and they overlap each other, and it makes it look like this. Well, I've studied this very carefully, and as far as I'm concerned, that pretty much is how an atom is constructed. Okay, my friends, I promise you, I swear Geek Fest will come up, but I always get sidetracked, and I got sidetracked on these Einstein rings today as I was setting up for the Geek Fest. That to me is an atomic structure, whether it's a molecule or an atom or whatnot, but this is in space. They claim, well, I'll show you what they claim in a second, but look at that carefully. This really represents dipole electron flood theory elegantly. And it's in space, and they found another one here that has 4 little bumps sticking right around it. Very, very brilliant. And I'm going to try to explain to you what these bumps are, why these bumps are here, and why is this structure out there. And this one here, this was the killer. Why? You see these little bump, brilliant, then a little less brilliant, and then this color, and then way out on the outside, you can just barely see them. There's more stuff out there, but you almost can't see it. You see it? And then you have these spikes coming out of there. I think I now start to understand the meaning of these things. And you see how more brilliant that is in this one, and that one there? I mean, it's hard to see. But I think they're leaving gaps for attachments in these areas here. And this would be what was called a ligand. It's an attachment molecule, I think. All right, now I'm going to go through this kind of quick. This is a dipole proton. All right, dipole electrons make up everything, but the dark part can go right to the center. I never realized, I always thought they had to be stuck together so there would be like a homogeneous mix of black and white. It's not that way. The black goes right to the center, which is dark matter, literally, which creates gravity because everything has the white matter attached to it. Everything you see here is white matter bouncing back at you. We're made of dark matter. Inside the white matter, which always bounces back at you, is this. But you would never see it because it's inside of a bunch of stuff that bounces back colors at you. That's why it's dark matter. And they say almost everything is dark matter. Well, that's because it's inside of light. And that's gravity. And the Earth is literally, we're standing on dark matter primarily. There's a lot of white in there too. But primarily it's the dark matter. And that's why gravity. And the denser you can make this, the more intense the gravity will become, which means the more black you have, the more white gets attracted and the harder it gets attracted. That's why I was so drawn to this particle in space. Now, think about this. We're not seeing any spikes sticking off here. This is what you would call a stable proton. It doesn't want any more particles coming, and it doesn't want to give any up. However, that's not the case in chemistry. All right, this is the case in chemistry. I talked about ligands. These are transition metals, which are ligands. All right, well, they carry ligands around. These are the different transition metals, and these are different charges. What does a charge mean? It means it wants to grab a hold of something else, or it wants to give some of it to somebody else to share. And that's how they transport molecules through your body, through these charges. These are transition metals. Now, I'm just going to read to you what it says. Very simple. Transition metals form colored compounds and complexes. They make colors. And the colors are because of the different energy levels that they create when they bond. The energy levels are what gives off the different colors. Now, so depending on the charge, on the metal ion, which is the central core, the metal ion. Ion means it doesn't have the correct number of electrons, dipole electrons, to be stable. That's what an ion is. It means it has too many little tiny particles. Hold on. I don't want to lose you here. That's the metal core. All right. And it doesn't have the right amount. If it had exactly the correct amount, it'd be here. It wouldn't want any more. It wouldn't want to give any up. But in this case, it's got a plus charge to it. All right, so it wants to take on other molecules around here, other atoms, to grab to it to complete its charge, to make it basically stable. And as it goes through the body, and it transitions through the body through these aqueous solutions, which is water, the ions form complexes with other colors and other molecules and other things in your body. As simple as that. And here they are right here. These are the ones, the transition metals, primarily. I think almost everything in here is well, I think everything does transfer you through your body, all of that. But these are the ones primarily in the blood. Your blood consists of almost entirely transition metals and serum plasma, which is, this is what it is. It's made out of, they just did a study, well, not just, but a while back, of 26 different metals in the blood, and the quantities and what's average and what's normal and what causes issues and But that was 26, and there was still tons more. Right? This is the area primarily that transfers things in. Mostly it's iron, Fe. But they jump back and forth and they drop, and that's what an ion is. An ion says, I'll give you a couple of these and you give me a couple of those, and that's how they travel through. They don't just drop off chunks of carbon and chunks of this and chunks of that. They might a little here and there, but not much. Mostly it's broken down with enzymes into little tiny bitty pieces. And they give them off and they take some on. But deep inside of every atom that we ever look at is the dark particle that we never saw before. This is in front of us. This is all dark matter right in front of me right now, traveling through the air. I did a paper back in 2015. It was called, I forget what it's called, but the basis of it was light is dark energy and dark matter as it transits space. That's all it is, coming out of the sun. You see it coming out of the sun, and then it goes nowhere. Well, it goes somewhere. It's just out there. You just don't see it until it hits our atmosphere, and then you get a glow like that Einstein ring. All right, so Einstein rings. This is the brand new one I just found. And this is only right down the street from us, or in our backyard, basically. And this baby is glowing like crazy in the center. That's got a lot of energy. Now, there's 4 little bumps here. And I believe it's spinning. And I believe it's spinning this way. And I believe that's like a little energy trail there. I'm thinking that it's heading this way and the front of it is bumping and causing a little trail to form in the back, the same way this way. Whenever you have a concussion of energy against anything that's out there in space, because everything is something, There is no empty space, none whatsoever. That has to plow through something. And when it does, the leading tip of it starts to glow, and you get a little fade because it loses energy back here. All the energy is being absorbed there. And I believe this thing is spinning in this direction. But I also believe there is an intense amount of energy right here, which is because it is such a tiny particle. But they call it an Einstein ring. They say, oh, somewhere behind it, this is energy lensing around us. No, that's not true. I believe this is somewhere down around the hydrogen range, which is the most explosive there is. If you broke this, I think the whole thing would come into a billion zillion pieces. When you're down around here, everything is held so tight. It's just, don't you dare try to get me out of there. And if you do, I'm going and everything's going. And that's what happens when hydrogen goes off. It's just unbelievable. And hydrogen is that tiny little particle. Now, hydrogen is only supposed to have two, or it's only supposed to have one electron. They just don't understand. Hydrogen is just the smallest stable bunch of particles. That's all. That's all. And inside that stable bunch of particles, way down inside that white is the black. You're never going to see it. This white is so attached to that black that it's just held there like, and if you snap one of these, they all go. Everything goes like crazy. Now, why are these out here? At this point right now, whatever black is in here is coated by these white, and there's no more wants to get in. It says, no, we got enough. We are what you'd consider stable. And these say, we want to get in. And they say, no, you can't. And they say, we want to get in. And they say, no. And this guy says, I've got so much magnetism, and they all have the same amount of magnetism. So they end up collecting in what's called a quantum distance from the core. A lot of the standard fits in, but it doesn't until you start to take in dipole electron flood theory. Then everything fits. But inside is where the dark matter is. You can't see the dark matter. The only way you can see the dark matter is if you can get the dark matter outside of the white and put it on top of the white. And that's what we did by putting it through the Venturi. And that's what CERN does by smashing it to bits in Fermilab and all of them, Livermore. All right, so they find these Einstein rings all over the place, and they don't know what to make of them. So they say, oh, this light is bending around it, causing these patterns. That's just not correct. Don't forget, we have an intense amount of light, a little less. Then we have this starting to be a blue color, which to me is really tight. This is so tight, it's just brilliant. And this is tight, and this is a little less, and then you get to where they just don't have a lot of energy left. But you can see them. If you look careful, you can see that. Hold on, let me turn this off. Sometimes that gets a little better. Is that any better? Maybe, maybe not. But this is still energy out here. It's just less energy. Extreme amount of energy, a little less. Then we start to get into the blue, the green, yellow, red spectrum out to where there's almost no energy. However, there are pockets. You see this bump here? That's not the same energy as these. And this one here sticking out into that little pocket, this is different. These other ones line up with each other. But these pockets drive out a spike. I believe something right in here might be able to hold on to it. I think I mentioned before what we call a ligand, which is an attachment. Now, this is in outer space, though, so all I can tell you is that's where it is. And they know they're all over the place. And they have no accounting for this. And this is so brilliant. I think this is down in the hydrogen range. And that's the brilliant core. It's still got a brilliant core, but this has a lot more baggage. So it makes it less explosive. You want to see what happens when hydrogen explodes? Let me show you something. Just so to get, this is very, very simple. Ligands are ions. Those are particles like this that don't have enough, or they have too many of these. And they're not really neutral, and they bond to a central metal atom ion. which is the metal that's in the center, and these want to grab a hold of some of those guys' electrons, and they share some. So they got a chunk here added to a chunk there. Whoops, there goes my dark matter. It fell right to the ground. All right, my friends, this is just incredible. This is the visible spectrum right here. And it's a very, very small piece of the entire spectrum of light. Light is nothing more than vibration and frequency. Now look at down here. You see the red, and then you go into the yellow, and then you go into the blue, and then you go into this purplish look, and it's gone. At a certain point, you have what's called the ultraviolet catastrophe, and that happens right here. Right there is the ultraviolet catastrophe. I'm not kidding you. Watch. The light is coming in through a prism. Here it's got very little energy. It's because it's being all absorbed by the prism. So it's down here and it's being shifted far into the red spectrum, almost to where you can't see it. Oh, here there's just no light. And here you're just starting to see a little bit of red, a little bit of energy. And it's getting a little brighter. And then it gets up brighter into the yellow. And then you get into the green and the blue where it starts to just get crazy. This is where really it's green. You can't really see the green until you look right at the edge. It's just too bright. Well, why is it so bright there? Well, because it's not so energetic here. It's more energetic here. It's highly energetic here. And then it's extremely energetic here. And then it's ultra energetic here, which is the blue spectrum part, which creates the ultraviolet catastrophe. You say, oh, what's ultraviolet catastrophe? Well, it's where there's so much energy that you lose the light. And you say, how could that happen? More light means more energy. That's why it's a catastrophe, because they can't figure it out. They say it gets brighter, and all of a sudden it goes down to dark again. Why? Why would it go down to dark again? Well, I know why. It's because the ultraviolet catastrophe lost all of its white. All right, let's go over this one more time. This is going to be a geek fest in the chemistry area and light, because they're associated to each other. This is the light coming in where it doesn't have enough energy. You're down here in the infrared. There's energy coming in, but it's so weak. Particles of light spin. They don't flap like a wave. They spin, and it is a particle, and it spins just like this. So it spins, but the spin is very elongated down here. It's spinning kind of slow. So when it bangs into something, it's not a big deal. Radio waves. This is sound. Sound is down here. Sound is nothing more than extremely slow light. Everything is vibration. Tesla was exactly correct. Everything is vibration. So it vibrates in here. If it's vibrating faster and faster and faster, you get into microwaves, which just shake water. They're not really fast. Microwaves are slow, but they just have that tendency to be able to shake water to heat it up. Then you get into infrared, where they hit your face and all that, and you feel nice and warm. So you're getting a little more energy. Then you get into visible, which is sort of a strange area, which gives you these spectrums of light. And what happens here is they bounce off of the frequencies or the actual distances of the electrons that are surrounding the core. In other words, all these different colors are a product. Oh, there goes my dark matter again. You cannot keep your hands on dark matter. Each reason, you see this whole chart right here. Just let's take the chart. Why are we seeing all those different colors? Why would you think different colors are coming back from that chart? It was shining the same light on it. I didn't change the light here to here to here to here to here. No. It's the same light. Same thing here. I shot the light through here. Well, why are these different colors going through the same piece of glass, which is a prism? A prism just means it's cut on an angle. There's more mass in front of the light here. There's less mass, and less mass. And at the very, very low end of the mass, it can drive those particles off. I believe that's what's going on there. Because here it's hitting and sort of dampening it down and getting slower, and it gives you the red. But here it's less stoppage, and you're getting brighter, and it gets brighter, 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 and it gets so bright that all the brightness is absorbed and only get black coming out of it. It's a little tricky. It might go the other way around, to be honest with you. I might have this backwards. Let me think about this for a minute. This is what research is all about. Hold on. All right, I can make this extremely simple because it is. This is light coming in. If it's coming in slow, it's going slow like this. Well, what does that mean? It's spinning. So the particle is pushing its own field in front of it. So this is the particle. This stuff goes away as it spins. It's just to show you how it spins. Now, when that particle is far away from its other particle, the wave, the distance of the magnetism is separated, so there's not a lot of push. When they get closer, coming down here, they get tighter and tighter and tighter, and they get tighter and they push harder and harder and harder, and they're closer and closer. So this field pushes that field, and it's, and then by the time it gets out to here, it's pushed so hard that it shoots off the white, all the white go, and all you have left is black. There is no white left. That's when you're out into the damaging particles, okay? So you get out past the ultraviolet catastrophe, you're into X-rays and gamma rays. Those are the things that kill you, because there's nothing but black particles there. All the white ones just shot off, and you ended up with just black ones. Those are killers, because it's nothing but mass. Okay, my friends, before we get started, I just want to tell you right now, we have discovered things that no human being in history could have possibly ever known about. They went out to Bennu, which is this asteroid, and they came back with this sample from Bennu. And this is biology, because that was a heart from a creature, gigantic creature. So is Psyche, another heart. They came back with these samples. It's phosphates with sarcomeres and another phosphate layer and more sarcomeres, and it is identical to heart attack victims here on Earth. That's the phosphate layer. That's the phosphate layer, and these blocks are sarcomeres. They pull in like this to make the heart pulsate. Sarcomeres, phosphate layers. What did they come back from Bennu with? The exact identical thing. Phosphate layers, and they said phosphate surprise. We never expected this. What's these layers doing here? A layer of phosphate, a layer of sarcomeres, another layer of phosphates, another layer of sarcomeres, because it's a muscle. It's a heart muscle, and these are the sarcomeres up close. And if you look close at the bundles, you can see these are heart bundles. These are muscle fibers. They're not just there for nothing. Same over here. You can see them. They're floating around here and there, but you got layer after layer after layer of phosphates, and then in between you have these sarcomeres, which are muscle sarcomeres. And they found all of the chemistry. They found the DNA, the RNA, the uracil, 16,000 organic molecules, basically the red fleshy clay that makes up muscle. And they found the anatomy. They found everything that is 100% certain is biology. 16 of the 20 amino acids, which are very, very complex little molecules. And I think they can do more with this very easily once they get their head around the fact that they're looking at biology. And they just can't get it. And I've been really pushing hard against these people. I was on live, and they finally cut me off. But all of this stuff in space is biology, even this here. You see that? That's Comet 67P. You look at that and you say, well, that's just not a rock in space. And this thing is gigantic, I'll show you. That's a hip joint. You say, well, hip joint, what the hell is that doing in space? I don't know. All I know is they said there was battles in the heaven, and that hip joint is right here. This is what a hip joint is. It's exactly what it is. And it broke off somewhere down around here. And that's the hip joint. It's out in space. And when it got close to the sun, it started cooking and giving off barbecue gases. You say, oh, come on, Roger, that can't be true. Well, it is true, because here they are right here. The sun is hitting right down into that artery, and that artery, guess how big that artery is? Just think in your mind, what is the biggest artery you could possibly imagine? How big is the biggest artery that you could possibly imagine? That's 500 feet across. 500. These are the little tiny blood vessels that come up to feed the muscle that was wrapped around this hip. And now the sun is hitting right into those. And they're shooting straight up because of where the blood vessel led to. Just like these are going off to the side. There must have been some stuff they were feeding that was out here that was wrapped around. And they're shooting off to wherever the vessel is fed, pointed. That's why they're little jets. And that baby is huge because it's the artery. Now this goes back to 2015. When I saw this, I knew exactly what it was. And I tried to report to everybody. I said, you got biology all over the place out there. And then when they landed Curiosity, I had the same thing. Curiosity on Mars, and Mars is there. They landed on Mars. Don't give me all this stuff. Don't trust anything you see. It's all fake. No, I know what I see. I see things that, yes, some things are fake, but when I see them, I can understand because I do a little more research than the average person. Their just mind is just, or I'll take anything. You show me something, I'll believe it. No, I don't believe much, and I don't accept anything without investigating it. That's just my nature, and I understand what I see. So don't give me all that nonsense about no Mars and no this and that. When they went to Mars, they found all the same biology. They found the same sarcomeres. They're all over Mars. They found the Mars Morse code, the Mars crab, the Mars blueberries, the same as the Moki marbles. Biology is 100% everywhere, and these body parts are. So how big could things get? If an artery is 500 feet across, maybe arteries could be 10,000 million miles across. We have no idea where we are right now. None. Zero. Now, I followed this mission from day one. This is the European Space Agency, and it was called the Philae lander. And they landed somewhere down in here, I think. And this is a bundle of, I believe this is a muscle bundle. These are tendons. And all over this hip joint, you have to have muscles and tendons, and it's got to be pulled this way and pulled that way and flexible this way and flexible. This is a very sophisticated device, and it is very large. The actual lander, you could never even see it in here. You'd never even know it was there. And this thing here on top of Raleigh, North Carolina, which is right here, that's Raleigh, North Carolina. I don't know why they chose that place, but that's where it is. And this is the size of 67P. It's Comet Churyenko or something like that. That's good size. And the only place it boils off gases is where you have these big arteries. Now that could be the artery right there. But let me show you how big that artery is. If that could be it, I don't know. It just looks like a round hole to me. And there's going to be blood inside of wherever that artery was. Okay, this is also from NASA, which is just not true at all. They're saying these layers in Mars, and again, this is Mars because you don't see any water erosion here, not even a drop of water erosion. This is impossible to happen on Devon Island or wherever you want to claim this happened. It happened on Mars because they landed on Mars, the Curiosity rover, and I'm going to show you some other shots. It's the same as Earth. It has all these gigantic creatures were on there, and they got wiped out when it got hit by Venus. We almost got hit. That's why it wiped out all our giant creatures too. This was let me show you. This right here is connective tissue. These blocks right here are where they pull in because this is muscle. And the red stuff eroding out of it is nothing more than, like on Earth, it turns into mud. All right, now they're saying this happened over millions and millions of years. Oh, millions of years out there. No, absolutely not. That is muscle sarcomeres. And this right here is the Mars crab. That is an artery. These are blood vessels. These are the sarcomeres that artery was feeding to make this giant creature, whatever it is, do whatever it was doing. And they did the same crazy stuff here on Earth. So don't tell me this is not factual. And again, no erosion. So don't tell me this is not on Mars. This drives me crazy. I mean, oh, not on Mars, you're not on Mars. There is no Mars. Same thing here. This is the Mars Morse code. You say, whoa, what the hell is that? That's skin pinched together. That's skin pinched together. That's skin stretched apart. That's skin stretched and bumped up and eroded down to the point where you just have the basement layer of skin, and it is once again zero water erosion. Zero. None. That means none. No water is falling. No water is collecting and causing piles of mud to show up. This is dusted off. Extremely elegantly dusted. You don't get any better than that. And this is skin not bunched up. This is exactly what is below the outside layer of tissue. Is this stuff which brings all that tissue back together. Once you stretch it and pull it back together, it's got to come back to a comfortable place. This is pinched. This is pinched. This is stretched. This has been stretched and eroded from dusting, because it is Mars and there is no water erosion. Capiche? All right, let me just wrap it up and finish up this case. I've been making the statements that everything in space is biology, like this hip joint. Even Mao is a finger, as a Mao is actual finger. These are hearts, Psyche and Bennu. Bennu, they have a piece back here on Earth, and it is a heart. 67P is gassing off like a barbecue grill. The astronauts take their suits off after a spacewalk, and they say it smells like sirloin. This is it's just fully understood. Space is saturated with barbecue gases. Even God said he liked the smell of it. I'm serious, that was true. That's what God said. And I showed you the muscles, and I showed you the sarcomeres, and I showed you the Morse code, which is up on Mars, that has not eroded. And this is the Morse code, which is actually interstitium in your body. This is the same stuff, exact same stuff. Now, why is the balls are tough as hell. The brown stuff is pretty tough. That's the stretchy little strappy stuff. And then this is the gooey floppy stuff that just erodes away. And you end up with these pockets in between. And sometimes if you squitch it together, they're very close. If you pull it apart, they're not so close. And they stretch. And guess what you see? Right here, it's that same identical thing. That's it right there. There is no difference. And those balls are tough. And they create what they call the Moki marbles, which they also call the Mars blueberries. These are the Mars blueberries. This is basement layer of skin. These are those interstitium balls that had at one time collagen, little flappy stuff, kerogens and collagens, that were those little stretchy little things. Those go away, the balls remain, because they're almost all, metals primarily. Now, I showed you the 500-foot blood vessel. I believe, maybe I didn't. All these little tiny balls here, they call them dragon balls. The reason they're there is because that's blood. That's where the blood went in to service the tissue. So I showed you that. I showed you the Mars blueberries. We've seen the stuff that came back from Bennu is nothing more than heart tissue, and Bennu is a heart. We've seen that 67P is gassing off because of the artery there and the little bitty blood vessels there. We've seen the Einstein ring. That's what started this whole thing. I was going to do the Geek Fest. We're going to get into the electricity and all the other stuff soon, but you got to understand, right now we're just lost. We don't know anything about anything. Because what you've been told to say is you've been told to say it. And once we find out it isn't true, well, it isn't true. If it isn't true, it isn't true. So what do? You got to find out for yourself. You got to try to understand what you see. Ask them to look at that and say, what do they see there? Well, I know I can tell you exactly what I see. I see magnetic fields. I see dipoles. I see interaction I see the moon. I see a blue crushing effect on the moon. I see this stuff, which yikes. And I see all of these magnetic fields. As they radiate outwards, they lose energy. When they're very compressed, they're going, brrr. It's as simple as that. And when they're down in this range of compression, they're tight. Each one of these has its own field. That's what a Tesla coil is. It's all wrapped up like this, real tight. And it is, as the electricity runs through a Tesla coil, it tries to push each other one apart. And they create these huge fields like this. And as you get further apart, the field just doesn't hold together, and that's the end of the field. That's what a Tesla coil is, you know. That's all it is you've crushed the fields into one tight ball. And then it just has to make it a huge field surrounding it. We had one when I was a kid. It was just stunningly powerful. And it was made out of a big, long piece of cardboard tubing where I forget what something was wrapped in it. Anyway, took the tubing and we put all this magnetic wire back and forth at this guy's machine shop and created a huge Tesla coil. And then we had it connected to an iron rod that was the resistor. And then for capacitors, we had some glass. This goes way back. But glass panels coated with aluminum foil and so forth. And it started all out with a Jacob's ladder electric arc. When you hear, there are millions of amps. You hear, me, boop, me, boop. That's what we started with, that much energy. Put it into the Tesla coil, and the Tesla coil would shut down the TVs in the town. It was unbelievably powerful. You could walk out like 40 feet and still hold a fluorescent tube in the air, and it would light up. I'm telling you, that was amazing. We had stuff, we were crazy kids. We were out of our minds. But it was fun. Okay, I gotta go. Geek Fest coming up soon. It's time to reevaluate literally everything. Oh, you have to open your mind up. Because once you shut down and say, I don't want to see it, it just doesn't, it can't be real. Then you're lost. Because all you can do is repeat what you've been told to say. And that's what a piece of paper is now, a degree. In geology, history, even chemistry, physics, all that stuff is wrong. We can accelerate light, not a problem at all. We can split light, not a problem at all. We can see light, not a problem at all. We can see Higgs fields, not a problem at all. We can see light spin, not a problem at all. We can see the particles, no problemo. We can see a particle nobody's ever seen before, and I have only seen one, and I have seen more particles than anybody in history. So, and again, it ain't bragging if it's true, it's extremely true. And that, my friends, is it for today. I love you all, and we're going to see everything. We're going to try to find out everything. They've already created black holes in space. They just didn't know what they did. This was out in the Russians did it. During the experiment, we contacted the Earth guys who couldn't believe it either, and then they just let it drop. I know what happened here. Based on dipole electron flood theory, they don't. And I got to go back and examine this again, now knowing what I know. This goes back to 2015, 2014 maybe. And at the same time I contacted the Russians about this, I contacted Fermilab, which again has been a disaster from day one with Fermilab. And I showed the particles that Don Lincoln showed. There's Don Lincoln's particles right there. Those are the two particles. This is him. And I contacted him, and it didn't go well, and it's still not going well. And they won't listen because it changes everything. We found those particles, and we could split those particles, and we did it for almost nothing. And those particles are the same particles I show right here. Here's his picture, and here's ours. The black one, he says, has a glowy edge around it. Well, yes. This one can get big and get small. This one never changes size. This one can get big, yes. It can get small, yes. However, we can actually split them at the venturi and keep the black away from the white. And I can tell you right now, and you can see it yourself, the black is on top of the white. And that's the only reason, and that's the onlyest reason that you can see the black is because it's on top of the white. The black everywhere. Black. But you can't see it until it obscures the white, because it doesn't absorb, it doesn't emit, and it doesn't reflect. It's just there, and it's the mass. So that's the mass, and this is the energy. Very, very simple. Anyway, I gotta go. We're gonna do the Geek Fest, and it's just gonna go over and over this stuff, and at some point we gotta get this organized a little better, but I just go off on these rampages here, and like I said, you're going to come with me or you're not. It's up to you. All right, I love you all. We'll talk again soon, I'm sure. Goodbye.